Efficient and reliable public transport has long since ceased to be something that a city hopes to have, but instead has become the backbone upon which a city is built. Without a public transport system, travel in the city would come to a standstill, with the roads being clogged with traffic and the air with pollution. Focusing on existing technologies that have already been used in larger scale applications, we will examine how to digitally transform a public transport system, using Brisbane's Translink as an example, in order to increase value and satisfaction for the customers. Cost or affordability was one of the first constraints that we found when examining Translink, scoring only a 51% satisfaction rating with customers. But Translink, like many other public transport networks, is heavily subsidized by the government, as it only makes a fraction of that back in revenue. It is highly unlikely that the cost would come down in any significant way. So, because of that, we've decided improving the service offered would be our primary focus for the transformation.
In order to facilitate improving the service, we looked at the data collected in the March 2014 Translink Customer Satisfaction Survey, as well as previous surveys. After cost, reliability and frequency was most in need of improvement, with a rating of only 65%. The GoCard system allows for a great deal of data to be collected on customer travel, and has been used in the past to identify adjustments to the network. However, there are other tools available to assist with refining the network and improving reliability and frequency of services. Human detection software, something that's been used extensively in CCTV systems, can be used to not just monitor the number of passengers using transport, but also the numbers waiting for transport. Identifying issues and allowing the possibility of adjustments to the network in real time is one of the key benefits of including such a system in our transformation. Getting information to the customer about what is happening within the network and how best to utilize the service is just as important. Currently, Translink operates a website with a journey planner utility, but has no mobile presence beyond that site. A mobile app able to let a user know where the services they want to take are in the network, displaying them on a map with exactly how long until they arrive, all accessed through an easy-to-use interface, would go a long way to improving customer satisfaction. Including the ability to easily top up a GoCard through a mobile device, rather than a long login process on their website, a slow machine, or visiting a retailer, would simplify the process for the consumer. So that users can take advantage of this new mobile solution, the free Wi-Fi currently offered on some Translink services could be expanded and mobile device charging points introduced, utilizing solar power in order to offset the cost. In order to not ignore customers without a mobile device, the same GPS-based location system will be displayed at major stations, allowing travelers to quickly and easily locate where the transport service they want to take is, and more importantly, know that that information is accurate. Static timetables can only be as accurate as predictions and cannot adjust to changes in the network. With the ability to top up GoCards, track routes, and check timetables, the new mobile app will allow consumers to limit their interactions with the system, save time, and use the services provided more efficiently. At the moment, if a customer is on time for their scheduled bus, but only realizes that the GoCard has insufficient funds after boarding, they are often forced to get off the bus in order to top up their card, or purchase the more expensive paper tickets. However, with the use of the mobile app, customers will easily be able to keep track of their GoCard funds, and be able to top up their card within a fraction of the time. An added benefit to such an app would be the ability to include features such as audio feedback for visually impaired customers, who currently have difficulty reading the GoCard machines. The benefits don't just start when the customer reaches the station. Being able to see exactly where services are in the network, passengers can time their arrival at a station exactly. While inevitably, people will still miss their train or bus, they will no longer be able to blame it on the service arriving early. In addition to this, the introduction of free Wi-Fi means that the customers no longer have to use their own mobile data, while at the same time helping to make long journeys seem shorter. While the core product of public transport remains travel, the plan for improving the service offers additional value to the customer. While the app itself and the real-time analysis focus on improving that core feature, the additional inclusion of charging stations and Wi-Fi access represent new features. In Australia, 42% of the population 18 and over uses the internet on a mobile device, demonstrating that there is a huge potential user base for Wi-Fi. Statistics from 2012 show that there were 8.67 million smartphone users and 4.37 million tablet users in Australia, and those numbers have only risen in recent years. Non-smartphone penetration has surpassed the population of Australia itself, so offering features that benefit the majority of travellers is an excellent way to improve public opinion of the service. Additionally, choosing solar power as the power source for this upgraded service will reiterate the environmental benefits of public transport. Surveys have reported that 80% of the Australian population believe that climate change is happening, and roughly half of those believe people are responsible for it. So environmental benefits will have additional value for some travellers. One of our major goals with this transformation was to ensure that we used existing technology that had already seen use in similar or large-scale projects. This was to ensure that it was feasible right now without reliance on technology still in development. For the live monitoring of where buses and trains are in the network, we would primarily be making use of GPS, although wireless communication between the bus and stations would be used as an additional update tool to avoid the issues with underground stations and GPS. The current GoCard system already utilizes GPS, along with the connections to the central server holding GoCard details. This means that the hardware for creating the monitoring system is already largely in place, and implementation is primarily a software issue. A system similar to that proposed is already being trialled on specific bus lines. However, since the beginning of the trial in early 2012, there has been little to no initiative taken by Translink to further the project. Native mobile applications for the major mobile platforms would need to be developed in order to ensure the speed and reliability of the system. A payment system for topping up GoCards would also have to be integrated into the app, similar to the one on the current website. Like GPS systems, the hardware is largely in place for the human recognition and tracking system. Cameras and fiber optic connections already exist at busway stations, so it is primarily an issue of what to do with the data, rather than how to gather or transfer the data. Software and servers to analyze the data, however, would be needed. HOG, or histogram of orientated gradients, is a human detection technique that was first developed in 2005 and has since been improved with further iterations and testings. This technique could be used to accurately count travellers. Having charging devices and Wi-Fi availability on buses is one of the steps planned to encourage usage of the mobile app. Similar Wi-Fi systems have already been put in place on some trams in Brisbane and have been implemented on bus networks around the world. Routers to manage passenger wireless connections and transmitters to connect to the network infrastructure would be necessary, in addition to a software-based management system to limit user downloads and site availability. Solar cells on the roof of a bus could contribute to any additional power requirements generated by such a system, and the power needs of the device charging itself. In full daylight, the charging needs of a full bus of people could be managed by a single 250-watt solar array that would take up a fraction of the space on the roof. The theory of constraints was at the heart of our decisions regarding what to focus on and on identifying areas that would increase usage and improve customer sentiment. The theory explains that any system is limited from achieving its goals by constraints or limitations within the system, and that by targeting these limitations, more value can be generated. Surveys conducted by Translink offered a good sampling of customer opinion and identified where the service needed improvement. It was for this reason that we focused not just on improving reliability through data analysis and real-time service adjustment, but also on improving information visibility. While these at first might seem unrelated, customer assessment of reliability comes from existing information, primarily timetables. Better information accuracy and visibility will improve users' opinions on reliability on their own. Customer opinion ties into theories such as the actor network theory and the socio-technical theory. Both these theories establish that the technology interacts with people's social networks, and can be viewed negatively or positively, much like the way a person would be in those networks. How that technology fits into the already established network, and how it is viewed, affects how it is accepted. By not forcing people to adopt the mobile app, and addressing issues they have with the current system, we have looked at how the transformation will fit within the existing network in order to create a positive impact. Ensuring that the information is able to be easily accessed by the public is the most important step in creating public acceptance, and in turn the success of the transformation. The technology acceptance model demonstrates that perceived usefulness and perceived ease of use are the largest contributing factors to acceptance of a technology. Simplifying existing tasks and making the app easy to use will encourage adoption. This is also supported by the theory of planned behavior, which, when combined with the theory of reason to action, establishes that there are several factors that contribute to predicting if a person will undertake a certain behavior. One of these factors is perceived behavioral control, or how easy or difficult a user perceives that behavior will be to perform.
So, all in all, this transformation is not just another way for a company to make more money, and it's not a gimmick to advertise a product. It is a simple, practical, and tangible way to solve issues with much needed service, and bring real benefits for a wider range of people. From all of us here, we hope you agree.